Alright, time for another DraftPhysics.com, debatephysics.com also, but no one will debate the actual arguments or argue the arguments, argue the facts, argue the evidence. Nothing, because they're all despicable, lousy, rotten, stinking, religious, kooky cowards. Religious, kooky cowards. Well, anyway, not exactly great poetry, but good enough for this video. So anyway, so the Noah Charles asshole. I think I can call him one of those now. Anyway, I did attempt, he did respond, which is always the big mistake they make, right? Because they really don't have an argument, so they shouldn't even bother responding. So I was able to post a link. It did actually survive from my other channel. And so he did respond, and his first response was, I don't know, New Age babble, I don't know. They're cooking me over on anti-kinetic energy YouTube. And you're just like, whoa. I thought it was a troll comment. I was like, what the fuck? Is that his real account? It can't be his real account. But yeah, it's his account. I was like, what the fuck does that... What is that as a response? They're cooking me over on anti-kinetic energy YouTube. Anyway, so I responded with, I guess it's no surprise, but I don't even understand your comment. Can you answer a simple question? Did momentum or kinetic energy land human beings on the moon? Seems a reasonable and fair question to ask a physicist. I'm talking about the forces, and then I qualified it because yes, they'll say no, well, the rocket did. I'm talking about the forces used to get them there and gracefully merge with the surface. So obviously, I'm talking about the thrust things, the things regarding thrusting, moving the spaceship by expelling substance. Yes. And his answer is IIRC. So I don't know what that's code for, but it doesn't matter. It was rockets. I mean, just it's priceless. So he doesn't understand that momentum and kinetic energy have different answers to the question of how much thrust or energy did I just produce. I mean, momentum gives me one answer. That's, 1/10 of the answer that the kinetic energy theory is going to give me. It's worse, less, even bigger ratios of difference than that, like the bullet and the recoiling gun. Recoiling gun, 2 joules, bullet, 2,000 joules. Thousands to 1 differences in what the theory says you just did as energy and what you should expect as an equal and opposite reaction. So anyway, so then I said, more silly evasion. Ask a physicist a simple question, get a nonsense as an answer. One more try. If a 5 mass going 10 velocity is moving to the right and a 10 mass going 5 velocity is moving to the left, and they are tied together with a non-stretchable rope, I don't know, you have to always qualify things, which one wins the tug of war? So simple enough, again, question. Shouldn't a physicist be able to answer the simple frickin' question? And they won't answer it because, of course, the answer is, yeah, well, it's going to be a tie because our theory is nonsense. Our whole concept of energy is bullshit. All these stupid accelerator experiments are bullshit. Anytime we use 1/2 mv squared to calculate something, we're getting a bullshit answer. And they're too weaselly to man up, okay, and accept the fact that they believe in a mushy pile of duality nonsense. Momentum is the only form of energy in the universe. It's the only thing that moves and pushes anything anywhere. And these cowards won't deal with the subject, clearly. All right, so I'll move on to, he has posted a new video on the subject of energy. But unfortunately, it's just an hour and a half of contrived, crappy math. So I'll start the video anyway. We'll see if it goes anywhere, jump through it, but it's probably not going to say anything meaningful on the subject of energy. Probably. Hey, there's no pause button. Interesting. There it is. Found it. All right, that should work. Let's see if it's loud enough and such.
Hi, and welcome to Lecture 5, in which we're going to start talking about energy. Now, energy is a notion that you've probably encountered in introductory physics as well as just out there in the world. And I want to give a sort of different take than maybe what you've seen before.
Oh, like they all say something like, okay, yes, I'm doing something original, except I'm just reading out of textbooks. Thank you very much.
In particular, I want to talk about why energy is useful when we're doing the
All right, so when we're doing, yes, what?
kinds of quantitative calculations.
There you go, calculations. Not when we're doing reality. So you do all these calculations that are completely useless. Again, you can use the kinetic energy calculation for the thrust coming out of a rocket, and it's absolutely meaningless because that calculation is not what the rocket's getting. The equal and opposite reaction is going to be momentum. That's what's going to make the rocket move, is momentum. And that's an absolute fact. Okay, that's what's going to move it in space. That's what's going to land you on the moon, is momentum. And all this crap mathematics that they do has nothing to do with reality, because they'll never show you the experiment where they actually measure what they collect. So as long as they don't measure what they collect, they can make up stories about, oh, there was all kinds of deformation and things got hot and oh, this happened and that. Oh, there's all kinds of losses and yeah. So they can make the argument, right? You collect almost no kinetic energy in your ballistic pendulum. So the ballistic pendulum has 2,000 joules go in. It collects 1.6. That's it, 1.6 of 2,000. And their argument is the other 1,998.4 is somehow in the pendulum somewhere. It's scalaring inside of the pendulum. Complete bullshit. No evidence that happens. None. Zero. And yet they sit there and just, try to pervert young minds with this nonsense. They have no evidence for it. It fails all these tests. It fails the lever balance test. That says nope, doesn't work. Fails Hooke's law. Fails all of these tests, and they just keep selling this crap because they can do math, not because they can show you experiments.
That we're focusing on so much in this course. So the one thing that's really clearly true about energy from the first time that we encounter it is that energy is a scalar.
Yeah, so somehow we encounter scalar energy. So isn't that just such a silly joke? That somewhere in our world there's energy without a direction, that there's energy that doesn't know where it's going, that isn't a vector. Okay, it's just like saying we've encountered the bent light when no, we don't encounter any of this bent light bullshit, and certainly not entangled or superimposed light. So it's just, it's just such a deception to try to imply, oh look, you've all seen the scalar light, haven't you? You've seen the scalar energy, haven't you? You run into it all the time. Where something has a whole bunch of energy but isn't going anywhere.
Quantity. In all of its different forms.
So where are its different forms? So give me the example of where this energy ever does anything called work. If it can't do work, I'm not going to notice it, frankly. It has to actually make something change. It has to make something happen. And even heat does that. Heat, they're going to say heat's a scalar of some kind. Well, we know it migrates across things. We can see it move.
Most of the kinds of equations that we've been dealing with so far in this course are vector equations.
Right, because that's the only thing that makes any goddamn sense. That's right, everything's a vector. Every single thing that happens in the universe has something to do with a frickin' vector. Because everything is basically made out of a force, okay? See those little things in the background? Everything's decided by that crap, okay? And it's moving in vectors. That's what the little lines are. Vectors. The whole universe runs on vectors. That Galileo, Newton, and Descartes were getting that, okay? And you, instead of standing on their shoulders, you kick them into the dirt, okay, to make up your own religion.
Scalar real numbers have a number of nice properties that vectors don't have.
It's just too silly. It's magical. That's it. Yeah, they have this magical capacity to do magical things that you'll never see. And that's all they have. They're invisible. Yeah, that's really cool. So it's like the invisible man physics. We can make things happen we don't have to explain, like bent space. We don't have to explain how it gives something energy when it doesn't have any energy. No, we don't have to explain that. We're physicists. We just tell you a story and you're supposed to believe it because you're dumb, doopy, silly assholes. We're smart and you're stupid, so you believe everything we say. Oh, it's so pathetic.
The most obvious of these is that scalar quantities are ordered. I can say whether or not one scalar quantity is bigger than.
Oh, yeah, well, you could do that with the vector thing, too. It's all about the length. How long is your vector? So that'll tell you what its whole magnitude is, yeah. You can do all that, so there's no advantage with the scalar. So the scalar has a very big one, but it doesn't have any length. Yes, it doesn't have any direction. Yeah, so it's probably not useful for anything. It's a non-directed length of magnitude. Oh, charming. Oh, just one of the little harassers. They're really such little deviant pleasures they get. Oh, can I harass him during one of his videos? Let's see if I can do that. Oh, it's just so pathetic. For years, people do this. For years. Yeah, this is their passion. Fuck, because I don't believe in their religion. We must stop him. You know, he's a non-believer. I mean, it really is pathetic.
And another, so 2.5 is bigger than 0.8. But I can't do the same thing for two vectors. In fact, to do so would require me to define what mathematicians would call a discontinuous map. So
that doesn't make any sense, right? I mean, obviously the vector has everything a scalar has, plus, okay, it's pointed in a direction. Wow. There's no difference otherwise. Just nonsense.
At least if I'm going to do it, I can't do it in a nice way.
BS, bullshit, and such.
This means that if we can use some sort of scalar quantity to define our motion, or at least to describe...
Define our motion. I mean, just can you imagine? He's saying the word, can we use a non-directed, non-pointed in a direction motion? Somehow this makes sense to these people. And it makes sense to you people. You sit there and listen to him just say something this stupid. Here, I invented this notion of something that doesn't have any, just has magnitude, but it hasn't any direction. And then he just talks about motion. How the fuck do you have non-directed motion? Motion everywhere? Motion what? How motion? It's just such junk.
Describe our motion, we have some hope of being able to say that certain points in an object's trajectory, for instance...
So we have a trajectory that's a scalar. No, you can't do this, okay? You're just cheating.
...are characterized by some quantity which goes up and down, and we can say how much it went up and down over time.
So again, more nonsense. So we know that this isn't what energy does, okay? We don't, the elemental universe doesn't do whatever up and down is. So more bullshit.
Okay, so that's just...
Volcanoes either erupt or don't erupt, you know, come on. You know, I'm deciding, oops, I erupted, but yeah, I haven't decided yet.
A little bit of background into why we might be trying to go the direction that we are, trying to describe our motion.
We are. So he's got you all going, right? Let's get this bandwagon of bullshit going. Let's keep pushing it and see where it goes, because it's just so much fun to go in no direction.
As much as possible using scalar quantities. We'll end up talking much more about this sort of approach when we get to Hamiltonian mechanics much later.
Right, which is just based on 1/2 mv squared. So again, it's just mechanics that has as its totem, okay, a non-existent pile of rubbish as a truth somehow. That somehow this has something to do with squaring anything. Velocity r seconds. When, of course, it doesn't.
Of course. For now, we're just going to start diving in to some of the concepts that you're probably...
So yes, he's probably going to, this is going to be another one of those videos where you're saying, who are you talking to? Because most of what he's going to write is for somebody who's already got 3 or 4 years of physics. and then he's going to talk like they haven't heard of what a whatever it is, something just so basic.
Familiar with from an introductory course. The first of these is kinetic energy.
So this is the part, right? So he does this silly simpleton thing, and then the rest of the video is going to be all of this abstract math. It doesn't make any sense. Anybody who can do your abstract math already knows what the difference between potential energy and active energy is. So again, this is more of the wordplay. So they've stolen the concept of energy, stolen the idea of what active energy is. So active energy is now kinetic energy. So they're forcing active energy not to be momentum, but to be whatever kinetic energy is. So this is where they've perverted the vocabulary, so you can't even say a word without them saying, well, that means this. It's like diffraction, lots of words, they've stolen them and said, oh, only a wave can diffract. Bullshit.
So the kinetic energy,
I was expecting that. All right, we are back.
here we go, and this is a definition. We'll say that
Absolute nonsense should be the definition. So he's called it T for whatever reason. So kinetic energy is T.
T is equal to 1/2 m, the absolute value or the magnitude of the velocity vector squared. Hopefully not too new for any of you.
Right, so this is the first time I've ever seen it written this way, and he says it's not too new. And I've watched hundreds of lectures by, qualified, Professor Lewin, real physicists. And I've never seen this notation of r squared, whatever the fuck that could mean regarding a velocity squared. But anyway.
And, of course, we've worked with this quantity before in a 100 level physics class.
Right, well, I don't know, we did. And you never really explained its origins, okay? God failed Leibniz. He wanted to be called von Leibniz. Pushed this crap. The Newtonians completely buried it, okay, by just bringing up arguments like, well, the lever proves it's nonsense. So it's nonsense. All right, let's move on. Then it was resurrected by a woman tutored by a Leibnizian. All right, and she was able to, she was rich, she could publish, and she even, kind of wallowed in the fun of publishing under fake names so she could pretend to be a man and show how women can do stuff and all of that kind of horse shit. So there was a whole backstory to that, all right? And it was all premised on really silly experiments in the sense that a real scientist could figure out that the experiments were fundamentally flawed in their logic, that denting clay with round objects is not going to be a nice linear test of energy. It's going to give you the wrong impression, okay? Rolling things on a surface is going to give you the wrong impression because you have to understand the other variable of gravity. It rolls twice as far, it only does it in twice the time, it's only in the gravity twice as long, all those kinds of arguments. A real physicist could understand it. See, so these people think they're physicists, think they've acquired some kind of knowledge, and they can't even figure out these simple things, that, experiments always have variables in them, and you have to account for all the variables. So they just sit there and shoot a formula at you and say it's the truth. And it's only the truth in certain circumstances, and you just do the experiment a little different, you get a different outcome.
But we need to start to maybe take a more formal approach to thinking about it. And we'll do that right away by looking at the derivative of t with respect to time.
So whatever t is, I guess it's torque again. So he's saying torque equals this, I guess. Who knows?
So let's do that right away. Take a time derivative.
He has to write out this crap. Like somebody needs that. It's like somebody could read it anyway. So, we'll critique this asshole because he's now proven himself to be just a douche. I mean, parroting what comes, he's read some abstract books, some math books, and so he thinks he has the special knowledge, and he doesn't have shit.
So I'll have that t dot is equal to 1/2 and m are, well, they're just scalar constants.
Yeah, that's right. They're always constants. That's right. The mass is always going to be a constant in all these equations, so you can ignore it. And then 1/2 is a constant, obviously, so you can ignore it. That's all because you want to shove it into a unit that you've pre-ordered a unit, and you want it to fit that pre-ordered unit.
So they go right through the derivative. And now I'm going to re-express this in a different way. So let me put my ddt in here. And I'll express the magnitude.
ddt. Yeah, this is their whatever. So again, all this is really saying is you measure velocity, okay, using this fractional approach, which is very dangerous because it becomes a rate, okay, and the velocity itself isn't really a rate. Its volume is really just about how fast it's going, and we have no way to express how fast it's going without measuring it as a rate. So it's our poor way of measuring the magnitude that requires this breakdown. But you really could just say velocity as an abstract, as a single number. You could just give it a number for the velocity, and you don't need the meters per second or any other qualifier if you didn't already force everything to be in your units
of the velocity squared instead by saying that this is the dot product of r dot with itself. Now I know what to do.
So just saying that these are two separate quantities and you can choose to multiply them or just compare them, I guess that's what the dot product is. It's showing it's separated the function of direction and magnitude, which is velocity.
Do with this, I can just use the product rule. All of the vector products, the dot product, cross product, all obey the product rule. So we're all good there. So this is going to be 1/2
says him
m times r double dot r dot plus r dot r double dot.
Yeah, so says him. So again, this is so abstract, so useless. This is somehow a simplification of 1/2 mv squared. I don't think it is. I don't think this is r dot double dot plus r dot double dot double dot. I don't think that's simplifying the concept of an increase in velocity, just pointing out that, look, the velocity increased. And certainly the square doesn't belong there because it's clearly not your velocity times your velocity is not your velocity. So, all nonsense. All right, so let's just jump ahead, see if he says
Between oat milk and almond milk, which should I drink?
Neither. It's a protein drink.
He ought to just put a big clump of ads in one place and leave it at that. I mean, what's the point of let's interrupt every 5 minutes for a stupid ad.
In time, so let me call that ti, to the end point of c in time, tf, of v of r of t, dot, and I didn't quite give myself enough space here.
So this is a case of, this is where they're showing calculus to be working. So he creates a fake line that no one can care about. So somehow there's balls rolling this way and there's balls rolling this way and they cause something to move this crooked path, and you want to find out, well, how far off a straight line is it or something like that. So you could draw your straight line, and then you could mark your little curves here that are off the straight line, and you start doing these integrals for each one of these bits. But the point is every time he draws this silly integral symbol, they never do that math. So they just leave that part out. So they never really do these equations. They're not as simple as they imply. Because what you actually have to do is do the one for this little movement here, get the tangent, do this little movement here, get the tangent, get this movement, do the tangent, and then you have to add all those up. So you might have to do 60 or 70 calculations before you can figure out what this was. It's not some simple process. It's a long, tedious process. And it's going to get you, an answer that who cares. But anyway, moving on. So he's writing it out again. So
Wait.
let's see if there's anything in this image that could care about. So this is just the cosine stuff, the force that comes at an angle. That's not terribly interesting.
Which, by the way, is root 2 over 2. There's no reason to put it in at the moment. All right. The key thing to notice is that these two forces in the y direction that are purely in the y direction.
So the fake normal force versus the gravitational force. So the gravity is the real force. The normal force isn't a real force. There's no real force. And the fact is that it all depends on what kind of surface it is. This is how much friction there's going to be. So this won't do you any good anyway, but you have to know what the friction of the surface is. The force doesn't mean anything if the surface, like ice or some other kind of surface that doesn't have any ability for friction to make much difference. It can't create much friction. Because that's all these two arrows are going to tell you, is how much contact you have with the surface. But contact matters, sandpaper versus ice. So this won't give you any standard good answer anyway. It's useless.
Okay. The force on the object at time t is equal to the force law evaluated at time, so whatever time we're talking about, plus the object's, not plus, but...
So it looks like he's doing the same thing. Let's just make an arbitrary crooked line and let's waste time calculating something meaningless. Oh, okay. Let's not talk about the fact that your theory that 8-pound bowling balls going 16 miles an hour don't actually knock down more pins than 16-pound balls going 8 miles an hour. And so this lie, your physics says it has twice the energy, is just that, a lie. It doesn't take 25 times the fuel. Oh, he's just wanking away. Alright, we is back. Let's see what the hell he's talking about.
And the object's position at that time, and the object's velocity at that time. Now, I'm sure that we could come up with an even more general definition of a force law, but all of the forces that we'll look at in this course are of this form. And I think you'll find that as you look through the possible forces that you can think of in nature...
All right, so let's just understand that he writes all this gibberish here, and it's just as simple as, okay, that we know all the forces moving the speed of light. We've already done the Planck constant thing, blah, blah, blah. And so that's sort of understood. And the forces that are pushing electrons and protons, we also know that's pretty static. And all they're doing is breaking the simple logic, because they're saying that, okay, if I can move an electron, faster and faster, I can quadratically increase its energy. When, no, you're not really doing that. It's not really happening. All you can do is change its momentum. You can't change its kinetic energy, because there's no such thing. And so they get these extraordinarily wrong answers to simple questions. So they think, helium nucleus flying through space and it crashes into the Earth's atmosphere, and they do this calculation of its speed, which is very high, and its mass, which is still small but higher than a single electron, and they come up with this preposterous amount of energy that it could knock over the Empire State Building. It's got so much kinetic energy. And it's just a nonsense statement. It doesn't have that, and that's why it doesn't do what they claim it does. It has energy, but nothing like what they claim it to have. And that's why they have to invent all these new particles, is because every time they do a calculation, they have a wrong answer for the actual energy, and then they test it to see how much energy there is, and it's not the thing's not adding up, so they have to invent some other particle that's taking the energy away, because their numbers say there's this much, and there isn't that much. And so then they pretend to say, well, now we've proven the existence of another particle because it must be carrying all that extra energy away. I mean, that's how neutrinos were invented. They had energy left over, and they just basically said, well, it must be some other particle that's leaving with the extra energy. Just bullshit.
And using it, applying it for...
So another silly crooked line. So this is like Gaussian crap. I mean, this has nothing to do with energy, frankly.
My force field. So Helmholtz theorem says that for a force, so let's say for a force field...
No, there really are no force fields.
Satisfying 1... So in other words, it's time independent. We have the following. F is equal to, well, let's just use this notation. I'm going to change here my phi to a u.
All right, forget it. It's really fascinating. All right, so now it gets even more mathematical. So here we have some of the cosine stuff. So that's just basically when something's at some angle. So you're not applying the energy at a straight line, and so you have to do the little Pythagorean thing of figuring out what portion of the energy is going in the right direction. But you don't have to use sines and cosines. You can do it a little bit more, a few more steps, but I would argue that just sticking with the Pythagorean notions and just taking your vectors and recognizing which way they're going, frankly, is more visually consistent with what's actually happening. I mean, to understand this line as a portion this way and a portion that way is a lot better than understanding it as a cosine or a sine. But anyway, that's my own preference. All right, so then over a pulley, this is when you're always going to lose a lot of energy to the fact that you are moving the pulley and the weights are pushing on the pulley and all of that kind of crap, and so you can't move something until you get the thing moving. So this is about static friction more than anything else. The problem with any of these experiments is that there is static friction.
G y naught over E naught.
Okay, not very interesting either. So again, this is just really, if you like doing math, then this is your fun time. But if you want to understand energy, it doesn't have anything to do with it, frankly. All right, so that's the whole video, is just this gibberish. All right, so we'll leave it there. But so you won't answer simple questions. So I can go through the bowling ball example. Why aren't the pros using the lighter ball? Any lighter ball will give them more energy by your theory. How come they can't find any of this extra energy? Ballistic pendulum. Do you really think that with all our technology, we're so disabled we can't collect the energy? We can't catch the bullet's energy. Not even a tiny. I mean, it is a tiny fraction. 0.06% of its energy. I mean, just such a tiny fraction. Do you think that's the truth? Is that, oh, somehow we're so disabled? Or do you think, oh yeah, well maybe the theory that there was 2,000 joules in the first place was nonsense? And the only advantage the bullet has is it delivers all of its energy in a very short amount of time. It's not that it has more energy. It's that it's delivering it in a shorter amount of time, and all of the substances in Earth, every single one of these substances is vulnerable to speed. The faster you can hit something, whatever his name was, what was the karate guy? That was basically the whole thing of that guy was that he figured out the physics and figured out that, yes, it's just about manifesting the speed. That's what you need, is the speed. The speed is everything. And so yeah, you can break the board with only an inch of distance, and he could punch something and break it, because he understood that all it's about is magnifying the speed. So if you use your whole body to create more motion, if you get everything in sync, you can create more velocity, and you can break something that wouldn't break otherwise. So it wasn't about more energy, it was just delivering it over a shorter and shorter period of time. And that's an advantage, but it doesn't mean you have more energy. You have to hit, there's hitting things in the right place makes all the difference. And that's how it works, is that it just requires you to hit it the way it needs to be hit. So it's the tipping point arguments. These are physicists. They don't even understand, they can't understand tipping points, and that's a perfect way of illustrating the importance of resonant frequencies, in the sense that you have to add energy while something's moving in the direction you want it to move. Because if it's moving in the opposite direction, you won't add energy to that system. You'll lose energy. Simple stuff. And no, they won't deal with the arguments. They just run away because they are just despicable cowards, proselytizing a silly frickin' religion, and they're pretending their religion is a science. when they haven't done any of the experiments. They haven't crashed cars. They didn't drop 4 pounds 1 foot and 1 pound 4 feet. They don't do the tug of war between the 5-ton train and the 10-ton train. They haven't done a single one of the fundamental experiments. They haven't proven any of this nonsense, and they just say our God is God. They're no better than crazy, babbling Muslims, just talking absolute shit. And you fools, you fucking idiots, defend them. They have no evidence for this crap. They haven't done elemental experiments, and you defend them. Why? Why are you defending that as a good use of neurons and brains? They're humiliating our intelligence by proving you can fool all of the people all of the time. Shit. So just, grow some integrity, smell the shit, and call it what it is. Shit. Okay.